can give only very, very short some hint in this part, in the second part. After a question by Piotr, we have some explanation. It is not, of course, even half of explanation, but just a direction of some argument, which use or involves fragmentability concept I mentioned before. Maybe I need to recall here what is fragmentability. The original definition sounds as follows. Let's say X is a set with a topological space. And let's say D, some metric space. No connection or assumptions between tau and D. And we say, or X is set to X tau. D fragmented if for every non-void part of X for every epsilon, one may choose a relatively open subset of A. I mean, we can choose an open subset, a tau open subset of a X such that first of all, the intersection is not empty, and the diameter of the intersection is less than epsilon. So this concept is very well known. It comes formally from Jane and Rogers. Including the name and usage, but non-formally, without any name, it was mentioned even much earlier by Namioka. And Fels. So, as you see, it's absolutely topological concept, but this concept was born in Banach space theory. Why? There are several good reasons. One of the big reasons was not unique, but one of the reasons was the interrelation between just weak star topology and non-topology in dual Banach space. So, many cases, in many interesting cases, our tau is a bounded part of a V star, or V star, weak star topology, V some Banach space, as usual. And D, of course, is just the metric of our dual norm. And the question is, what kind of subsets are fragmentable? the original questions. Why this question is interesting? There are many reasons, but as you know, if our V is infinite dimensional, always big star topology is weaker than the non-topology here. So the idea is to understand when big star topology and norm are close. What is close? Sometimes if X is some bounded compact subset in big star topology, of course bounded and closed big star topology, same. Sometimes we have some point continuity property. So for every subset, we can find something that has a restricted map is continuous for some special point. It's a kind of mimic of continuity. Continuity we can forget from continuity. As I mentioned, in infinite dimensional cases, we have no coincidence here. Continuity from tau to d. But many cases are quite close. What's quite close? One of the possibilities to evaluate is to say that it's fragmented, subset is fragmented. And one of the most powerful ideas in the Asplund Banach spaces is just a result, which is a result of many people's, that this property characterize Asplund Banach spaces. I already mentioned the definition Asplund Banach spaces, what was for every separable subset, the dual is again separate. But Asplund Banach spaces can be, the definition can be reformulated in terms of fragmentability this way. As V is Asplund, our Banach space is Asplund, if and only if. It's very well known, but for our results, it's very important result, that if and only if every bounded X into dual is fragmented. Again, our tau in big star topology is norm fragmented. Of course, it's equivalent to say that, because it's a hereditary property, fragmentability by definition, so it is equivalent to say that our B star is a non-fragmented. So now we can say something about the second part, at least for intuitive way, because in first lecture I prefer to give some introductory material. We need below we will introduce some family concept of fragmentability. What is family concept? If fragmentability comes as a kind to generalize continuity, we have in analysis we have continuity and equicontinuity for family. If we have some family, first of all, this definition of fragmentability, some ideas, okay? We can do this. So our original definition, it was for identity function. Okay? First of all, we can consider change our identity function, any function x tau into y, some d, or even some uniform space or some metric, because this definition is just uniform definition. It's not so important as metric. And take here some arbitrary function. The same way we can change our definition of fragmentability. So all definitions you can find in my below, and I will give it in full details.